Yes, sir.
Okay, thank you very much. Today we will continue. I'm sorry we started a bit late today. I was doing something today. I was just preparing the notes. Okay. Today we will just continue a little bit more on chapter 1.2. I forgot to cover this the last lecture. And following that, we will do chapter 1 as well, 1.3, basic about OS booting concept. Okay, so in the last lecture, we learned about multi-threading, we learned about monolithic kernel and what is a kernel. Okay, so let's just recap a bit more. What is a kernel? A kernel is a central unit inside the operating system. Okay, this green circle over here, this is the kernel. So where does the kernel sit? The kernel sits inside the operating system. Okay, kiranya you can say the kernel is the heart of the operating system lah. Without the kernel, the operating system would not function. Okay, so that's the basic idea. And the kernel, and in a microkernel, okay, microkernel, the kernel is divided. Okay, they are the separate kernel, tapi one kernel lah. So it's divided, and each kernel will take care of one hardware. So if you see here in the diagram here, the application software is right at the top, and this is the kernel over here, and the kernel will be in charge of all of these hardwares, which I've drawn over here. Okay, so in the microkernel, unit kecil, the kernel will, dalam kernel tu dibahagikan to a few subsection. So each of them will take care of one hardware. Okay, itu maksud dia microkernel. Kalau zaman dulu, we have something which is called the monolithic kernel. Kalau mono nu meaning it is one. Okay, so inside the operating system there is only one kernel. So when there is one kernel, meaning there can only be one process running at one particular time. So if we are talking about microkernel, we have micro, unit here very, very small, meaning each part of the kernel takes care of one particular hard disk or one software or one program. Kalau yang mono tu, it can only do one job at a time. But now we have moved into what we say is the hybrid kernel, meaning it can do both, micro pun boleh, mono pun boleh. So why do we need both? Sedangkan if you read the notes, you will find that a micro kernel is better as compared to a mono kernel. Okay, so there are some advantages. Why do we use a mono kernel and why do we use a micro kernel? Okay, if I give you an example of a mono kernel system, which is actually still available, dalam gambar raja saya yang tak ada kat sini. Okay, if you remember the picture I gave you about the operation room tu, okay, dalam bilik operation tu, the bed is there, and then ada sensor kat situ, and then there is some process going on. There's some screen available. So those are, some of it are what we say as a monokernel, meaning they will only do one process. Okay, I'll give you another simple example. Another simple example is when you go to the supermarket, when you check out your groceries, okay, when you go through the counter, that PC where the cashier uses is what we say as a monokernel, meaning there is one operating system which sits inside the cashier machine, and it only does one process, which is to check in, scan the barcode items and so on and so forth. So that is what we say as a monokernel. It only does one process. However, in the microkernel, it can do a few multiple process because each part of the kernel takes care of one particular software or one particular hardware. Okay, all right. But in the hybrid system, okay, and here a hybrid is a situation whereby it it can do a monokernel and it can do a microkernel. Okay, it can do both. Meaning you have a big software, you have a big operating system, or you have a big PC. One part can focus on something and another part can do so many other things. That is what I said. If you look at the example in chapter 1, I gave you a picture of the operation theatre. Dalam tu kan banyak screen, banyak TV. So one part of it, dia boleh check on the temperature of the patient. One part of the system can check tekanan darah dia, okay, and so many other things. So this is what we say as a a hybrid kernel. Hybrid kernel also we can say is inside your telephone, okay, your handphone is also what we say is a hybrid kernel system, whereby it can do multiple tasks and at the same time it can also do one particular task as well. For example, like when you on your camera light, okay, you on your camera light in your phone, okay, so the camera light is always on, okay, the torch light is on, but at the same time you can also snap pictures, you can download music, you can make a phone call, but that light is always on, okay, because it's doing two different things, okay. In a monokernel, it uses more CPU time, more processor time. Okay, so let's go on to multithreading. I think you know multithreading is what we say as a thread, a single job. For example, you open your Microsoft Word, that is one process. If you open a few documents, that is multiple threads or multi-threading. Okay, so multi-threading, the example given here is a thread is like electricity passing through the wire of the devices. Okay, if you close your Microsoft Word, that means automatically you will close all your documents. Okay, but if you close your documents, your Microsoft Word process is still available. Okay, are you with me? Saya cakap sorang-sorang ni.
Yes, sir.
Ada sir.
Ya, okay. Hari ni 20 orang tak datang kelas kita ni. Hari ni baru ada 47 of you. Okay, can you see my slides? Nampak?
Gelap, sir.
Dah gelap. Makin nampak.
Nampak.
Okay, besarkan sikit. Okay, next we move on into symmetrical multiprocessing. Okay, symmetrical multiprocessing, we take the last word first, multiprocessing. Multiprocessing means it can do a few processes at one particular time. Okay, however, is also what we say as a multiprocessor. Multiprocessor means you have a few processors in this picture running at the same time. Okay, so multiprocessing equals to multiprocessor, which means you have a few processors running at the same time. So in this picture, you have 1, 2, 3 processor or 1, 2, 3, 4 processors all running at the same time. But it only shares one RAM and it only shares one input-output device. Meaning to say, you can take, for example, 4 CPUs but connected to one keyboard, connected into one mouse, and at the same time, it only has one RAM size. The RAM size can be big, but it's all connected into one. Okay, so why do we need this multiprocessing? Okay, obviously, the main reason why we need multiprocessing is for faster process. Just imagine you have four CPUs running at the same time. You're all running at the same time. Okay, so if you're doing graphics, for example, you can do graphics in one side and then continue on a different side. You can download music, you can do so many other things. Okay, because you are running at a very, very high speed. Just imagine you have 3 or 4 3 or 4 laptops running at the same time. Okay, but you share only one memory and one input-output device. Okay. So in this case, this is what we say is a symmetrical multiprocessing. A symmetrical multiprocessing means it can all run the same process, or it can run different processes, okay, at the same time. It can perform multiple functions and so on and so forth. Okay, the opposite of symmetrical multiprocessing, okay, the opposite of symmetrical multiprocessing is what we say as asymmetrical multiprocessing. Ada perkataan A kat depan. Okay, asymmetrical multiprocessing. Asymmetrical multiprocessing is the same concept as multiprocessing. However, ini penting sikit ni. However, let's say you have 4 PCs, it can only run one process. However, proses ini dibahagikan sama rata to all these 4. Okay, you understand? If you don't understand, it's simply like this. Let's say you have a maths problem, masalah matematik. Okay, soalan dia ialah let's say 2 times 5, 5 times 2, 3 times 7, 7 times 4, and 5 times 2. Okay, ada 5 solution dia. And the question is, find out the total of all of this. So in asymmetrical multiprocessing, each of these equations are given to one PC to solve. Okay, given. So these PCs will solve all the mathematical problem, and answer dia, jawapan dia akan bagi balik dekat the main PC, okay, to compile the answer. Okay, to compile the answer. That's what we say is asymmetrical multiprocessing. The same job, the same one question, but it's divided into a few, and the answer will be compiled back again. Okay, another example of asymmetrical multiprocessing is, let's say you're working in a group of 5 people. Okay, a group of 5 people. Okay, A, B, orang number 1, number 2, number 3, number 4, number 5. Okay, 5 people. All right. In asymmetrical multiprocessing, there must always be one master, ketua dia lah. Okay, that's asymmetrical. Ada A kat depan. So dalam 5 orang ni, you choose one ketua. Okay, ketua nombor 1. Okay, so ahli nombor 2, 3, 4, 5. Okay, the second, third, and fourth and fifth becomes what we say as a slave. Hamba abdi lah. Okay, becomes a slave. So now you have a math problem. Soalan dia ialah to find out what is the total of something. Okay, so you give each member one problem to solve, and your team member will give you back the answer. Okay, so number 2 here will get one problem. Let's say soalan dia ialah 5 kali 2. Okay, done. Number 3 will get another problem. Let's say 7 times 3. Number 4 will get another problem. Let's say 10 times 2. And number 5 will get another problem. Let's say 10 times 30. Okay, and each of them will give the answer back to the master, and master will compile and come up with the answer. Okay, that is what we say is a asymmetrical multiprocessing. Okay, so dalam asymmetrical multiprocessing is usually done when you have a large proses yang sangat besar, and it takes a long time. Okay, a long time. So each PC will handle the same problem. Sorry, one problem will be divided into several PCs, and each PC will come with answer and recompile value inside your master. Okay, so you have a master, and all the other PCs become the slave. Okay, that is asymmetrical multiprocessing. Ada A kat depan. In a symmetrical multiprocessing, okay, you can run all the programs separately. Each of you do different things. So you have 5 people all working. Each of you get different tasks. However, each of you are sharing the same memory and sharing the same keyboard. Okay, So in this problem, kalau dalam symmetrical multiprocessing, who will get to access the keyboard first? Kata ada satu keyboard, but ada 5 orang nak guna. And all of these 5 people are doing different things. So you take time. So that's why when we talk about symmetrical multiprocessing, kita ada konsep time sharing. Okay, let's say 5 of you are running together. There's only one calculator. Okay, so each of you take time and finish it. Take time and finish it. Take time and finish it. Okay, in asymmetrical, all of you do individually, and then you only pass the answer back to the master. Okay, if you have any questions, you can type on the chat box. Saya boleh jawab. Ada soalan-soalan ke? Ada soalan-soalan ke? Tak ada? Halo, halo? No?
No, sir.
Okay, are you with me? Tak ada, sir. Tak ada, sir. Tak ada, sir. Tak ada, sir. Nur Amalina, Nur Amanina daripada 3B. Do you have any questions? Akila ada soalan, Umi Aisyah ada soalan, Nur Anis ada soalan tak? Aina Syafiyah ada soalan? No? No, sir. Okay, bagus. Faham, Okay.
InsyaAllah, okay, sir.
Okay, next we move on into what we say as the, nampak screen ni? Next we move on into what we say as the object-oriented programming language base. Okay, in an object-oriented programming base, it's nothing to do with programming. The concept saja. Konsep yang saya nak explain kat sini is the similar concept as how we do a object-oriented. Okay, kalau you masih ingat in object-oriented, you have the class, you have the object, things like that. Each class will have multiple objects, something like that. Each class has multiple objects, and each object will do only one function. The same thing is what we have in operating system. Okay, in the early operating system days, okay, ini gambar yang belah sini. Early operating system days, the OS is loaded entirely into the main memory, meaning to say, sorry, you have your RAM size, but when you load the operating system, all of the files will sit automatically inside your RAM. Which when you have all these files sitting inside your RAM, meaning your your RAM size will become smaller because part of it is all operating system files. Okay, and it will make the PC slower because your RAM size is now reduced. Okay. However, even if and then all these files are kept inside the operating system. All these operating system files are kept inside your RAM, even if you use or you don't use it. So there's a wastage of space inside the main memory. Okay, but in the new HPC object-oriented concept, it only loads. Okay, it only loads the operating system files which are really needed. Mana yang perlu sahaja dia akan masukkan dalam RAM, and that's it. Whenever it's not being utilized, it will go back to the hard disk. Okay, so what is the files yang what are the files yang which is not needed? Example, file management module, device management module, networking module. Okay, that means if you're not opening your file explorer, that particular file will be not inside your RAM. Okay, it will just sit inside your hard disk. So by doing this, your RAM size is smaller. When your RAM size is smaller, you can automatically, the PC can automatically run more programs. Okay, so let's say your device manager, it's not inside your RAM. Why is that so? For example, let's say you have a barcode reader, a QR code reader, okay, but you don't use it today, you don't use it now. So when you don't use it, automatically the file sits inside the hard disk. It is not on a ready mode. Dia bukannya ready kat situ. Dia baru nak buka. Okay. For example, even in your phone, if you want to access certain application, only then you double click on it or you click on it and it opens. Okay. You cannot just slide and find the program and just go in. No, it doesn't work that way. It is a program sits only when you need it, only then it goes in. Okay, so you can read the description here. Okay, all right, I'm moving on to chapter 1.3. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Saya dah uploadkan nota hari ni 1.2 ni. Yang bahagian yang these two slides ni is not in the notes of 1.2. I've already created another one which is called 1.2 and plus 1.23 to 4. So you can get it in my Google Classroom, and I will also nanti upload inside my new future. I forgot to upload. Okay, so next we move on into chapter 3 pula. Hold on. Have you all eaten? Dah makan dah?
No, sir.
Dah, sir. Dah.
Dah, sir.
Why have you not eaten? Yes, I will. I have a problem sebab hari tu the last class tu I tried to upload but the file is too big. Let me see what can I do with it. I have the file with me. I will try to upload again lah. Or else I will try to create a video which is not the class based. Saya akan cuba Anis, don't worry Okay. So siapa nak minum air boleh minum. So how has it been so
Alright.
far? Anis, are you okay? Anis, Suhana, are you okay at home? Are you going crazy ke apa tak? Anis says thank you. Okay. Sometimes I feel I'm just talking to my screen now. They are like your profile picture pun pelik profile picture you. Ada yang Hafiz, your profile picture is a rabbit. Amar, your profile picture is an Japanese anime. Hanani, your profile picture has a cat. Have you changed into a cat or something? Let me see what other profile pictures which are available. All right, so we have multiple profile pictures here. It's quite weird. With apa, we will Diana, your profile picture you're wearing a cap. Aiman, profile picture you cartoon. Siapa ni? Okay, all weird ones. So tak apalah, it's okay. Alright, let's move on to chapter 1.3. Okay, chapter 1.3. Can you see my slides?
Yes, sir.
Can, sir, can.
All right.
Yes, sir.
So chapter
Yes, sir.
1.3, we are talking about booting operating system. Sorry, not booting operating system. There's no such thing as booting operating system. We are talking about how does the operating system boot? Meaning, what does boot mean? From the time you switch on your PC until you see the first screen, there are certain steps that the operating system takes. So this is what we are talking about in chapter 1.3. What or how does the operating system be loaded inside your PC? Okay. This same concept is also applicable to other operating systems, such as Android on your phone, such as Linux, such as if you are using Mac, iOS. It's the same process. There are certain files which are different, but the boot process is the same. Okay, so how does this step 1, what does it go through? So we are hoping that by the end of this chapter, or by the end of chapter 1.3, or at least by the end of today's class, you should have a basic idea of how the operating system boots into your PC. Okay, all right. So there are certain steps you have to take. If you go through the notes, there are about 16 steps or more, but it's actually only 4 to 5 steps. Some of the steps is just additional notes as well, only. Okay, all right. The first thing you need to understand before I explain is what is a CPU or what is a processor. So saya dah dapatkan a picture here. Okay, this is a picture of a motherboard yang merah, yang hijau ini. This is a motherboard, and on the motherboard is what we say as a processor. So there are a few kinds of processors yang biasa ada. You have AMD, and you have so many other processors. So a processor sits on a motherboard, duduk di atas motherboard itu. So you cannot buy, you can change your motherboard, but you have to find out if the motherboard is compatible with your processor. Okay, some motherboards are compatible only with this kind of processor. Some processors are compatible only with this kind of motherboard. Okay, that's number 1. Next, number 2 is you have to understand what is a chipset. A chipset also sits on the motherboard. However, it is not part of the processor or the CPU. Okay, it's something by the side. All right. So when you first on your PC, the chipset will come to effect. Okay, chipset tu akan come to effect. Okay, before your processor starts, your chipset will come to effect. Chipset job is to reset whatever is inside the processor, is to clear whatever is inside the processor. Okay, is to clear whatever is inside the processor. Okay, that is the job of the chipset. Itu je. Okay, so step number 1, when you on, the chipset will generate a reset signal to the processor to clear whatever is inside the processor. Okay, now step number 2 pula. Okay, so we're done with step number 1. When the processor first starts up, there's nothing at all in the memory. Okay, so this memory which I mentioned here is the RAM. Okay, so as you know, any process which needs to run, it needs to be put inside the RAM. So when the first thing, when you on your PC, there's nothing in your RAM. So now there needs to be something to be put inside your RAM in order for the operating system to be loaded and in order for the operating system to be run. Okay, so the first program which comes up is coming up from your ROM, ROM, which is what we say as the BIOS program. Okay, so the BIOS program sits inside your ROM. So how does a ROM look like? It's something like this. How does a RAM look like? RAM looks like this. Okay, okay. So yang mula-mula tadi, so ROM will come up with a certain file. Okay, and this file will be loaded inside the memory. Kenapa dia nak load dalam ni adalah function dia, which I will explain. So where does it load? Kat mana dia nak letak? Sebab memory ni size dia besar. It's a big size. It has so many addresses. So where does the where does the BIOS load itself? Dia nak masukkan diri dia dalam tu. So it will load inside this instruction. FFF0H. H is hexadecimal. Okay. So why do you do that? Kenapa dia load dekat address ini sahaja? In any operating system or in any PC, the BIOS only loads at this particular location, this particular address. Why do you do that? Kenapa dia nak load this particular address? Okay. Why does it do that? It's because if there is some compatible issues. Hari ini your size of your memory is, let's say, 64 megabyte. tomorrow you buy a bigger one. When you buy a bigger one, your address will not increase. So that's why it is always set the ROM will load at this particular address, which is FFF0. Itu je. That's the reason. So BIOS dia akan load itself, masukkan diri dia dalam your RAM. Okay. Next, step number 3. So once dia dah masuk dalam ni, BIOS dah masuk. Next, daripada location FFFD, dia akan cari your operating system files inside your hard disk. Faham? You understand? Okay, are you with me?
Yes, sir.
Yes.
Yes.
Yes. Yes, sir.
BIOS masuk ke dalam ni. Okay, and then dah masuk ke sini. Pada sini dia akan cari kat mana file tu, which is inside the hard disk. Okay, which is inside the hard disk. Okay, next. Okay, that is step number 2. Okay, next, the operating system file yang dalam hard disk tu akan dibawa masuk ke dalam memory, and step number 3, BIOS will perform the test called power on self test, POST. Kenapa dia nak power on ni? Because it's going to find out if there's any problem with all the hard disk, with all the hardware. So one by one dia akan check. Dia akan check video card. Okay, dia akan check. Okay, we'll check one by one. We will check the ROM. So we will check the hard disk until it displays the screen. Okay, dia akan check one by one. This is what we say is the post. Okay, power on self test. If there's any problem, nanti dia akan keluar a certain sound or beep. Okay, next. So all of this it will do lah one by one. You can read on this. Okay, next we have to understand. Okay, so these are the steps. Dia ada macam-macam step lah. Okay, okay. Next, what you need to understand is what are the files which are involved. So bila you bergerak, bila the BIOS takes the file from the operating system, it cannot just take any file. It has to take specific file for the operating system to run inside your memory. Okay, so inside a Windows operating system, so di bahagian atas ini, these are the files which is needed in order for the operating system to run inside the PC. Okay, so these are the files. Okay, these are the files here. Without these files, the operating system cannot run inside the PC. Where are these files located? These files are located inside the hard disk. However, in order for the PC to run, these files will be now taken into the RAM. Okay, taken inside the RAM. Okay, if you are looking at your Linux operating system, berbeza sedikit. These are the files yang bawah ni. These are the files which I needed. Okay, you don't have to understand all these new threads atau apa. You just need to look at these are the files. Nampak ni? /x87, 86 kernel. These are the file names which are important. Okay. All right. Are you with me?
Yes.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Let me just stop for a while. I want to show you. I have another slide, tapi I just want to show you a picture. Topic. Show you a topic. Okay, can you see this file? Okay, can you see this slide?
Yes.
Yes, sir.
Okay, this will make you understand a bit more. Okay, when you on your PC, bila you tekan button on itu, okay, this happens. The BIOS daripada luar ni, BIOS will load itself. Dia akan load diri dia ke dalam your RAM, which is your main memory. Okay, apa yang dia akan load? Dia akan load something which is called the bootstrap program. At what location? Yang tadi tu, FFF0H tu. Apa tugas this file? This file's job is to read the operating system from the disk, hard disk lah. File apa yang dibaca? Yang tadi saya explain tu. Ada beberapa file. Okay, bila dia nak baca, then dia akan loadkan file ini masuk ke dalam operating system. Masuk ke dalam main memory. Okay, so bootstrap program's job is only to load the operating system ke sini. Okay, so it will find the file and load it. Itu je kerja dia. Bootstrap program's job is to locate the operating system files inside the hard disk and load it back inside your main memory or your RAM. Okay, so once dia dah load masuk dalam, the operating system will do a post test. Tadi saya explain tu, which will check on all the drivers which are available, which is this one. What is a post test? A post test is this. Okay. Power on self-test is to check on all the devices which are now connected to the personal computer. Okay, they are going to check that. Okay, so you have the bootstrap program. So what is the function of the bootstrap program? The bootstrap program function dia ialah dua benda. Kena ingat ni. What kalau soalan keluar? Okay, what is the function of the bootstrap program? Okay, the bootstrap program has two functions. Function number one, to locate the operating system files inside the hard disk. Function number two, once it has located the files, the bootstrap program loads the operating system file into the main memory or the RAM. Okay, so this is very important. What is the function of a bootstrap program? To locate and to load. Locate what? Locate the operating system files inside the hard disk. Next, to load the files inside the main memory. Are you with me?
Yes,
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So this is the most important thing for today. And then when you are loading, example, when you are loading Windows file, these are the files. Nampak ni kat atas ni, CPROM ni semua. These are the files which are needed, okay, to load the operating system in the main memory. So file-file apa yang di load? So inilah dia file-file dia. This is particularly for Windows operating system. If we are talking about Linux operating system, what are the files? So these are the files. int main, c432. Okay, these are the files. Okay, so biasa soalan-soalan exam ni dia akan tanya, what are the files needed? What operating system files are loaded inside your main memory if you're running on Windows? So jawapan dia ialah, if we are running Windows operating systems, these are the files which are loaded into the main memory. So if the question asks you, okay, what are the file types or what are the files of Linux operating system which is loaded into the main memory? So the files are, inilah file dia, int main 432 and so on until here, till down here. Okay, right. Okay, let's. We have one more slide before we stop for today. Saya nampak, saya rasa lah you tengah pening. Okay, there are two booting concepts that you need to know. One is what we say as the cold boot concept, and one we say as the warm boot concept. Okay, dia ada dua. A cold boot concept ialah whereby when the machine is totally off pagi-pagi, then you do a cold boot process. And the warm boot process ialah you do it macam you restart sahaja. What is the difference between a cold and a warm boot? A cold boot does the post test. Okay, dia akan check satu-satu hardware tu. Post test ni. This one. Okay, post test. If you do a warm boot, which is control alternate delete pun boleh, then you will not do the post test. Okay. So sometimes even you do it on your phone, if you restart your PC, it's different, or you take out your battery, it's different. Okay, so if you're talking about your phone, then you take out your battery, you put in back, you reload, that is what we say is a cold boot. If it's on your PC, okay, you restart, or you don't restart, sorry, you start up every morning, that is what we say is a cold boot concept. Start. Okay, if you're talking about warm boot, you just restart. So restart, kenapa you nak restart? Maybe sometimes your RAM to the overflow, or maybe you have some problems. So you just restart. So when you restart, it's much more faster because it does not do the post test. Okay. All right, I will stop here at at slide number 17. I will continue back on next Monday. Okay. Before that, do you have any questions? Macam start engine kereta time pagi, sir. Something like that lah. But engine kereta tak boleh lah restart kan? Engine kereta, yeah, something like that. But engine kereta is always, even though you say as memang lah engine tu dah panas kan, but sometimes it's like that lah. You can use the concept there a bit, but it's not the same actually of starting your engine early morning and ni lah. Okay, do you have any questions?
No, sir.
No, sir.
Okay. Okay. Right. I will share this video later on. Okay. So thank you very much. I'll see you back on Monday, and we will continue on Monday from slide number 17.
Thank you, sir.
Okay. Thank you very much. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Waalaikumsalam. Thank you, sir.
Thank you, sir.